and this is my project submission for managing machine learning projects. This is a peer graded assignment as part of the Duke University and Coursera program on machine learning projects managing. Now, the grading criteria is, or the way PRs are supposed to evaluate this presentation is based on the opportunity evaluation. Did I clearly explain what the problem is about? Crisp business understanding. Did I properly document the problem, clearly define what success looks like in terms of outcome and output metrics, and identify relevant factors? Validation plan. Did I explain a plan for validating the solution concept with potential users? ML system design. The way I designed this ML. Did I describe the key system level architecture decisions and the potential risks in production? Did I describe possible drift concerns or other potential issues that the model might be facing? So based on all these criteria, the project is supposed to be evaluated. Now, as a premise of the project or the problem at hand is energy management in the telco world. Now we all know that globally energy management has become more important than ever, and in the telco world, where 10 to 30% of the overall network OPEX is spent on energy, which is a huge amount of money, that is a huge area of concern for any telco today in the world. So globally, there are a lot of sustainability targets across telcos, across governments to reduce their energy consumption. With this in mind, when we get into the telco understanding of the telco world, we understand that the RAN equipments on the site, which acts as the transmitter and receiver of the signals from individual mobile subscriptions. So those equipments run 24 cross 7. Now, there are low traffic hours, or let's say there are some time when there is no traffic at all. So is there a way to predict when can I switch off those telco RAN equipments during low peak hours? So the project at hand is reducing the telco RAN energy consumption during low traffic hours without impacting the customer experience or the major network KPIs. The objective is to predict low traffic periods in a telecom network using AI/ML and automate RAN cell locking and unlocking to save energy without harming the network performance. So as I explained, means can we do that? Now, evaluating the opportunity. This is a strong AI/ML use case for three reasons. One is it is pattern based. The telecom traffic follows predictable daily and weekly pattern, making it well suited for modeling. Now, let's say in a weekday, during morning hours or during office hours, the traffic will be high. Evening as well, the traffic are on the higher side. But then post 10 o'clock, let's say the traffic will start falling down. And from night, let's say 12 o'clock to morning 5 or 6 o'clock, there will be very less traffic on the network, right? So it follows a regular pattern. Of course there can be uncertainty, or there can be exceptions. Let's say when there is a World Cup match ongoing night time, or New Year, 31st December, New Year night. So there can be there will be different behaviors, but those behaviors as well can be identified. So these are pattern based behaviors. Now, availability of the data. So every RAN equipments are continuously sending and storing this data in the central server. So network generate this huge volume of traffic, and KPI data can be leveraged, which are getting stored in a central repository and which are normally available for at least 3 months. Now, business value, as if we can reduce even 2% of energy consumption on the sites for a telco network, just imagine the amount of money you can save. I'm talking about millions and billions of dollars. Now, CRISP DM framework, we know about this framework: business understanding, data preparation, modeling, evaluation, and deployment. So I followed all these concepts in order to understand and in order to work out the project. Now, business understanding, the objective here is to use the ML to safely reduce energy usage by predicting and acting on how low on low traffic periods. Now, the success of the metrics would be the outcome would be percentage reduction in the energy use and stability of the customer KPIs, whether I'm able to reduce X% of energy without impacting any customer KPIs. That's one of the success metrics. The other output is the model prediction accuracy and actuation success rate. So two things are there. One is the model prediction accuracy, how accurately the model is predicting the locking hours. And secondly, the actuation engine, how successfully it is able to actuate. Now, what happens normally is when you're predicting, let's say night 12 to morning 6, you can lock this cell, and then the actuation engine goes to actually lock those cells and then finds out that there is traffic, so it is not able to do, right? So that would talk about the model prediction accuracy and also whether I am able to successfully actuate or not. So that's my output metric. Now, the relevant features here are the historical traffic, the time of the day, week, seasonality, geographic location, and prior KPI impact from locking. What happens? So, this is the basic business understanding of the ML project. Now, solution validation plan. My approach was to backtest on historical data, simulate cell locking effects on the KPIs, and simulate on a test data. Let's say I'm talking about 100 sites data I'm taking for 2 months of data I'm taking of 100 sites, and then creating the model and then testing it over some sites to see what effects the locking will have on my KPIs. And this test cluster that I have, I monitor the KPIs and the energy savings on that, and based on that, I can expand this entire energy savings to the entire network and say that, well, if I'm able to save, let's say $100 on your 100 sites, then on your, let's say, 5,000 sites, I can save this amount of money in a year. So that's the kind of output I'm looking at, and then refine based on feedback and results the model itself, based on the accuracy, based on the output accuracy. I can keep on refining the model. Now, the ML system design decisions, like first is the interference type, batch or the daily prediction, simpler and cost effective. The second is retraining frequency, weekly, or uh, keep the model updated with recent trends, because as we know that telecom network traffic keeps on constantly evolving and moving, right? You can have higher traffic in some months and lower traffic in some other months. So weekly, as the data is available, this weekly training the model is a good idea. Then human in the loop, definitely semi-automated during pilot especially, and then when the model is working to a precise value, to an acceptable value, and we can replicate or we can expand it to the entire network, this can be done closed loop and definitely with human eyes onto it. So when we are keeping it semi-automated, it builds the operator trust and allows safe adjustments time to time. Now, risk in production, the challenges is concept drift, sudden behavioral changes, holiday events, those things. Then training, the KPI shift during execution. So one is on the test data, and during execution, the KPIs might shift, and that might have wreak havoc on the network experience. So any operator, especially live, they would not want to play with their network KPIs because that would affect the customer experience and their brand image immensely. Then latency, locking actions must be well trained. So let's say I lock a cell, but then there is lock a cell as the traffic is low, but then there is an accident on the highway due to which the traffic starts piling up, and then you need to immediately unlock those cells because people will call their home and whatnot. And if they're not able to call because you have locked that cell, locked that RAN equipment, then that's a definite customer experience degradation. So that's why the latency is very important in this scenario. And over prediction risk, so false low traffic prediction degrade the service, as we understand. Means if you lock more, in order to save more energy, if you lock more, then there is always a possible risk of degrading the network KPIs and customer experience. Mitigation, regular retraining, drift monitoring, and fail-safe overrides. So in case there is a certain network surge, the system should be capable enough to understand that change and immediately unlock itself. Then only I will say that this model has worked well, and in terms of business outcomes, it has generated what it required to be. So the conclusion is, by leveraging ML to predict low traffic windows and automate cell management, telecom providers can reduce energy cost while maintaining service quality. The system is designed with operational safety, business impact, and model reliability in mind. So thank you. Thank you for your time.